Hello, my name is Jacob Wong, and this is my Paleoanthropology project. The fossil that I'll be discussing today is Australopithecus afarensis, often referred to as Lucy. So, who is Lucy? Lucy is a female member of an extinct species of Australopithecine that lived from around 3.9 to 2.9 million years ago in the Pliocene of East Africa. Lucy herself lived around 3.2 million years ago. How was Lucy discovered? She was discovered on November 24th, 1974 by Donald Johanson and Tom Gray in Ethiopia at a site called Hudar, which is the image on the screen. But on that day, Johanson and Gray had taken their Land Rover for another day of mapping and surveying for fossils. When they were done, they decided to head back to the vehicle so that they could return to their camp, but Johanson proposed that they take an alternate route back to the Land Rover through a nearby gully. And within moments, he spotted a right proximal ulna, or forearm bone, and observed that it was that of a hominin. Soon thereafter, he spotted an occipital bone, then a femur, some ribs, a pelvis, and a lower jaw. And this was a huge find. Within the following 2 weeks, they excavated, screened, and sorted several hundred fragments of bones that had been recovered from the site, and by the end, they had a 40% complete skeleton of a single hominin. Now, you might be wondering why this particular specimen has the nickname Lucy in the first place, and it actually has something to do with the beetles. So, after finding the fossil, their team had a night of celebration and they named the skeleton Lucy after the Beatles song Lucy in the Sky with Diamonds, and the name has stuck to this day. How do we know that Lucy's skeleton came from a single individual? We know this because while several hundred fragments of hominoid bones were discovered at the Lucy site, none of the bones were duplicates. If there had been a single duplication of any bone, it would have disproved the single skeleton claim, but conveniently, there is no such duplication in Lucy. Even more, if the fossil fragments belonged to more than one individual, we would have expected there to be more bones than could have existed in one individual. For example, if they had found 3 femurs instead of 1 or 2, we would have known that there had been more than one hominin present. However, this was not the case. They only found enough bone fragments to compose the one partial skeleton. Therefore, we were able to reasonably conclude that all the bones came from a single individual of a single species, size, and developmental age. Now, Lucy isn't the only Australopithecus afarensis that we have discovered, but it's really helpful and important to have these fossils that have so many bits of one individual, because that allows us to get a really good look at what the overall anatomical structures may have looked like. Lucy's skeleton is composed of 47 out of 207 bones, which you can see on the left image. This includes parts of the arms, legs, spine, ribs, and pelvis, as well as the lower jaw and several other skull fragments. However, most of the foot and the hand bones are missing. We assume that Lucy was a young adult at the time of her death based on the condition of her bones. It is predicted that she stood at around 3.5 feet and weighed somewhere between 60 and 65 pounds. And in fact, Australopithecus afarensis in general had smaller bodies, ranging from around 3 to 5 feet in height. I keep saying that Lucy was female, but how do we know this? Evidence from the fossils found at the Hadar site, in addition to a growing collection of Australopithecus afarensis fossils and knowledge about the species, suggests that this group had sexual dimorphism, apparent in the difference in size between the males who were relatively larger and the females who were relatively smaller. And based on Lucy's size, she clearly fits into the latter, which allows us to conclude that she is indeed a female. Australopithecus afarensis has both ape-like and human characteristics. Lucy's face proportions resemble that of apes with a flat nose, a strongly projecting lower jaw, a relatively small brain case, conical rib cage, and long, strong arms with curved fingers adapted for climbing trees. The top of her skull was also slightly domed, and the size of its brain, at around 450 cc, was comparable to that of chimpanzees. At the same time, however, she had small canine teeth similar to humans and was clearly capable of bipedal locomotion. This is apparent from not only the shape and positioning of her pelvis, which reflected a fully upright gait, but also from the curvature of her spine to the structure of her femur, ankle, foot, etc., which were all more human-like. At a site in Litoli, Tanzania, there is a roughly 27-meter long trail of fossilized footprints. These Litoli footprints date back to 3.6 million years ago and are reasonably assumed to have been made by Australopithecus afarensis because fossil bones from Australopithecus afarensis have been found nearby in the same sediment layer. This footprint trail is known as the Laetoli footprints and include about 70 early human footprints. The hominids that left these footprints behind were clearly bipedal and had big toes in line with the rest of their foot, which means that these early human feet were more human-like than ape-like. The footprints also show that the gait of these early humans was heel strike. In other words, the heel of the foot hits first, followed by the toe off, where the toes push off at the end of the stride. This is the way modern humans walk. The close spacing of the footprint supports the idea that the people who left them had a short stride, which most likely means short legs, such as the legs of Australopithecus afarensis. Excuse me. Although Lucy's pelvis, leg bones, and feet supported bipedal locomotion, her upper body was adapted for at least partial life in trees. Lucy's shoulder joint, in particular, hinted that she was probably a tree climber. The orientation of the joint indicates that she would have had a range of motion more conducive to pulling herself up in trees. And as you can see from the image, she had long curved phalanges, a cranially oriented shoulder joint, and relatively long forelimbs, all of which aided her life in trees. As stated by its name, Australopithecus afarensis belongs to the genus Australopithecus, a group of small-bodied and small-brained early hominin species that were capable of walking upright, but not well adapted for traveling long distances on the ground. Other species in this group include Australopithecus africanus, Australopithecus sediba, and Australopithecus anamensis. Australopithecus anamensis has been hypothesized to have been a direct ancestor to Australopithecus afarensis due to their morphological similarities. Similar to Australopithecus afarensis, Australopithecus anamensis has a combination of human-like and ape-like traits. The orientation of their ankle joint, in addition to the structure of their femur and tibia, are indicative of regular bipedal locomotion. Yet aspects of their wrist bones and their long forearms suggest that these individuals were also capable of climbing trees. While Australopithecus anamensis most closely resembles Australopithecus afarensis, they can be distinguished from many features. For one, Australopithecus anamensis has narrower, more parallel jaws and larger lower lateral incisors. Additionally, they have a unique upper canine morphology and a different structure of the lateral nasal aperture compared to Australopithecus afarensis. Australopithecus africanus, on the other hand, largely existed after Australopithecus afarensis went extinct. Australopithecus africanus shares many similarities with Australopithecus afarensis, but also has very distinct differences. The two species have similar postcranial morphology, exhibit a high degree of sexual dimorphism, and are capable of bipedal locomotion. Among the derived traits of Australopithecus africanus are a higher forehead, slightly larger cranial capacity, a less pronounced brow ridge, smaller canines, and smaller molars. Lucy's discovery was huge for the world of paleoanthropology. At the time of her discovery, she was the oldest, most complete hominid skeleton ever discovered. While Australopithecus afarensis wasn't the first member of the Australopith group to be discovered, its discovery confirmed the belief that our ancient relatives habitually walked upright, and more specifically, that this feature of the human lineage occurred long before the evolution of bigger brains. In other words, Lucy's fossil settled the debate as to which came first, a big brain or bipedal locomotion. Lucy was clearly bipedal, but she had a small brain case. As an upright walker, Lucy reinforced the concept that walking was a key selective pressure driving human evolution forwards. Bigger brains were not necessary for the first hominids to take defining steps away from apes. Extra brain power only came over a million years later with the arrival of Homo erectus. Though big brains would clearly be important later, walking remains one of the traits that makes us uniquely human. Thank you for listening.